Great. Thanks for joining us, guys. My name is Mac Rogers. I'm with Domino Data Lab. We've got a handful of things for you this afternoon. First, I want to start by thanking you for making it all the way to the end of Rev. This is your very last talk that you get to sit through, or have to sit through. If you guys like it so far, it was good. What you expected, at, above, around, below? Thumbs up, good. Great. So a brief background on myself. I've been at Domino for about a year and a half now. I work with our customers, so I'm out in the field working with you guys. Some of you guys are customers. Basically helping them do data science better, use Domino better, and to be more effective. One of the tools that we spend a lot of time working with is Jupyter. It's very extensible. We're going to talk about that a little bit, as well as some best practices and tips and tricks for how to make the most of it. So before I jump in, I want to do a brief survey of the folks in the room. How many of you are familiar with Jupyter or Jupyter Notebooks? Have you used it before? Good, good. I would consider yourself like expert heavy users or like light users, make ggplots every now and then? Okay, good. I gave a flavor of this talk at JupyterCon in New York last year, and that was very heavy Jupyter users. So I think a lot of the tips and tricks were already understood, but hopefully you guys will be impressed. So it won't be worthwhile. And so I'm also going to chat about Jupyter Lab, which has just released they just released the first stable beta this February, which is sort of the Jupyter project's vision for where Jupyter notebooks are going. So I think that would be really helpful. All right, so been at Domino for about a year and a half. I did like equity research in the finance world before coming to Domino, so I did a lot of stuff that people do who use Domino. Wishing I had Domino, found Domino, and decided to do something for them. For that, I was trained as a chemical engineer, which I've subsequently not used whatsoever. All right, so first I want to do a brief background. It sounds like people generally know what notebooks are, but just in case anyone feels out of the loop, the idea of a notebook was sort of spawned back in the early 90s with the idea of literate programming, which was sort of understanding that the way that software interacts with the computer isn't quite as important to the software writer as what they're thinking, what their logic process is, how they're thinking about what's happening. And so the whole idea of literate programming is that you're adding commentary and plain text English into the software that you're writing. If you take this a little bit further and start working with data, you now want to have exposition, explanation, the lineage of what you're working on alongside the actual code that's working with the data, and then the results of that work. And so it really bundles, the idea is to bundle the entire process into a single platform. And so I think Mathematica was one of the very first to introduce a notebook in the early, late 80s, early 90s. And it sort of crept along in the world of academia. And then Fernando Perez created the iPython project, I think in the early 2000s. Then our studio and created a Markdown. And so there's been the spread of this concept of a notebook across a few different languages and across different industries. Academia being one of the more influential ones, but it started to spread into industry the last decade or so. And so to sort of put this into context, I've borrowed Philip Guo's data science lifecycle, which if you've been paying attention to Rev, Domino has our own data science lifecycle that is very big and cumbersome and very effective at getting very detailed. But for the sake of this talk, I want to focus on sort of the high-level overview. This one is sufficient for that. Where the main thing that this is highlighting is that, of course, the iterative nature of going through many loops and various cycles with different goals in mind, and also the extensibility of the work that you do in this research process. So everything from exploring data and manipulating it and just cleaning it up, all the way to actually doing the circle of analysis where you write some scripts, run the scripts, look at the outputs, make some visuals, send it back to inspect, and then debug why it's not working, and then start over and over. All the way to actually reviewing the work, some final output that you have, and then disseminating that either to your peers, your colleagues, the rest of your organization. The reason I bring this up is not to talk about life cycles, though I'm always happy to do that afterwards. But mainly emphasize where a notebook, the concept of a notebook, code with commentary, with results, all bundled into one, how that fits into this life cycle. And really the answer is sort of everywhere. Because it's really easy to have, once you have a stable platform to start doing this sort of work in, or a stable foundation, that other people who may not be subject matter expertise or the same type of technologist as you are, if they have a similar formatting with which you can start to engage in the content, it really starts to break down barriers for communicating and sharing ideas. And so the idea behind where notebooks fit into this piece is that you can do everything from the actual data preparation and analysis inside of the same platform that you can then share with someone else. And so really, the most valuable thing as an individual is that the barrier to get the exploration or the lab notebook place that you've been working into someone else's hands is so much lower, because in reality it's just the same place. And so taking that last piece and sort of honing in on that, the idea is that there is a whole spectrum of ways that you can take your work and make it useful for other people, whether it's just a research project or an actual like reprogramming of how your entire like multinational corporation supports its hardware. It can be anything from a shiny app all the way to just an ad hoc report that gets run once a week. And so there's this whole spectrum where humans are ultimately the end goal or the end consumer of what you're working on. And they're able to understand things like easily formatted squares and boxes, as well as charts and graphics and plain text English. And that's sort of all of the notebook real estate. These are things that could live entirely in notebooks without having APIs and machines talking to machines. All right. So one more thing that I want to briefly cover is this idea of reproducibility in the context of this data science lifecycle. So if you're thinking about all of the analysis that you have to do, the reflection that you have to do to understand that why your analysis is behaving the way it is, how that impacts the actual data that you're using, how you're preparing it, and how that flows into what you're disseminating, there's this pretty important concept of will what I did work when someone else tries to do it? And so if you're like into the semantics of the thing, then it can get very, like, what is replicable versus reproducible can get very, very nubby. And if you like that, Mark Lieberman has a great language log blog where he has an entire post about what the difference is between the two, and the comments are about as exciting as you might expect. It's very, very pedantic. But the main point is that there's a spectrum, right? So like, did my computer just barf out the right answer? If it did it twice, then that's not really reproducible. It's still like an accident. So if I can consistently make sure that I'm not wrong about what I'm doing, like I actually understand what's happening, that's just like repeatable, I can repeat this. And then at the other end of the spectrum, it's the ability to document what you're doing so well that someone else can come back and do it by themselves. They may have different algorithms or different data sets, but if they're asking the same question and able to derive the same like hypothesis about why something is happening and prove or disprove that, then that's real reproducibility. And that's how you like build on the shoulders of giants inside of your organization, or just like as a researcher who's trying to understand something new or just compound upon knowledge that's already existed. All right, so that takes us to Jupyter Notebooks specifically. As I mentioned, there's a handful of different notebook types out there. Jupyter has sort of taken off. It originally, again, started by Fernando Perez, who was a PhD student, I think at Colorado, and he was working on his physics thesis and realized he wanted an easy way to explain what he was working on to other people, and so he built this, which is kind of impressive as a just like hobby, but for people like Wes McKinney or this guy, it's really something you just do. And so he created the iPython project, which was targeted specifically towards Python and a Jupyter notebook-like interface. Over time it evolved. He sort of like got the whole open source community rallied around this idea. And in 2014, they spun off the Jupyter project from the iPython project, which really focused on taking the fundamentals of the iPython notebook and abstracting it away from Python to Julia, Python, and R, which is where they get Jupyter from. And so really all it is just an HTML layer on top of these individual kernels. And after their first like push into the idea of abstracting notebooks away from a specific language or a specific tool set, the open source community sort of took that over. And now anything from, I think like PySpark is a thing, which is just Jupyter notebooks that run Spark. SAS has a Jupyter kernel, and so they're towing into the open source world. And I think Scala is also another really popular one. But the whole idea is you're able to run whatever language you like and do your analysis and whatever works for you, but you have a standard format and templatized way of sharing it with others and explaining what you've done. I'll also jump into Jupyter Lab briefly, where the two main ideas behind Jupyter Lab is it's the fundamental principles of Jupyter, where you're able to have the idea of a notebook, but really one of the biggest complaints about Jupyter is that it's not an IDE, and people who are more familiar with the terminal or the command line don't really get the same experience of writing code, kicking off a job, getting the results. And along with some other extensibility things, that's what Jupyter Lab is largely targeting. One of the beauties of like both Jupyter and especially Jupyter Lab, where they've like really honed in on this, is the idea that all of those features that you want are extensions. And so there's a handful of really cool ones for Jupyter Lab that we're baking into all of our Domino stuff, like having templatized notebooks. So like, hey, I want to work on a notebook that is like this, and you have like, here's your standard data calls, here's your standard visualization, here's how we document how we do work inside of our team. And so yeah, I assume time logger, time extension is no different. All right, so that's our preamble. With that, we're going to jump into some tips and tricks for Jupyter notebooks. I think this is zoomed in enough. I've hidden all sorts of things at the top. But the first thing I want to chat about briefly are magics. And so the idea behind magics is that they sort of let you out of your like huddled mass of notebook. And so everything that we're seeing here is all HTML. This is a little text cell. But the magic commands let me sort of reach behind the scenes and mess with the HTML or start doing other things. And so the most basic magic command is the magic command that tells you all of the magic commands. So you can see there's a whole lot of stuff here. I'm not going to run through all of them, though there are plenty of listicles online that will, that are very long. But there are a few that I want to pick out and sort of show you that I think are pretty helpful, pretty useful. The first one that's the most easiest to understand is the exclamation point. And all that's going to do is take whatever it comes after it and runs it as if it were in the terminal as a bash command. And so using this, because we're on a Linux machine, I'm going to get a list of all of the files inside of my project, who runs them, how big they are, all that simple stuff. Super useful, incredibly, like especially if you're working in something like Domino and you want to have a file browser outside of what you're normally using, just let you jump right there. You take this a step further and make commands that run, like instead of just having this one line run as bash command, make the whole cell. So by adding a couple percentages, a couple percent points, we can now do something like check all the versions of packages that have pandas in them. And so this same idea of like I'm reaching under the hood, doing stuff outside of Jupyter itself can be applied to the kernels themselves in a really cool way. So this simple command, which should give me the version of Python I'm using, is breaking because I'm trying to import these packages instead of importing them. So I don't have a great way to illustrate this, but it is one of the lesson learned things that I really like. If you hold down the Option button on a Mac and click, you can edit multiple lines at a time. And now we can fix all these at once. Yeah, that's one of the, I don't understand why this isn't more better known, but I love it. So if you're, I think it's Alt. I think Alt on Windows. And so yeah, so most of these imports are unnecessary, but this is Python 3.6. If we check out the Python kernel up here, it is consistent. But I actually wrote this a while ago in Python 2, and I'm very lazy, so I don't want to update all of my code. I just want to know what version of Python I'm using, and I want it to be the same as it was before, back before I was using Python 3, because again, very lazy. So there's a Python 2 magic. So just say, this is Python 2, and now this cell runs as Python 2. In particular, this one's 276. So if you're a Luddite and don't want to update all of your code, you can just use magics to get around that. But it's also useful outside of the world of just like not wanting to update from one version to the other. Data science doesn't really have any strong standards. It's very much do sort of what you want in the Wild West and see what happens. So a lot of people really like R. There's a great open source extension called RPY2, which will let you run R inside of Python, at least inside of Jupyter. And so now I can do something cool, like tell me what version of R I'm using in this R cell inside of this Python 3 Jupyter notebook. But I can even go a little further than that, and with some of the magics we were talking about, I'm going to use pandas, pull out the iris data set, visualize that just to make sure it hasn't changed in 30 years. And because I'm also, again, I'm lazy, I want to use ggplot because that's my favorite viz tool, but I had to pull in pandas, use pandas to pull in the data frame because that's all I know how to use. So I'm going to pass this data frame into R using the magic and plot the data set using ggplot. And so now I'm using basically just, again, if this was real work, then it would make a lot more sense why this is worth doing. I'm using the excuse that I'm lazy, but sometimes this level of transformation of going from one version of Python to another and then to R, because that's just where you know that one package works, can be a huge time saver. I probably wouldn't recommend like breaking the HTML of Jupyter notebooks in order to do production work, but for the exploratory analysis that is like 80% of what a data scientist does, makes it really easy to switch to whatever tool fits whatever thing you're trying to do. And so a few other miscellaneous things. Latex is a really popular way to render complicated formulas. This one works sort of as you'd expect. There's a whole world of information about how to write latex commands or latex functions. You can also bring in HTML. And then because Jupyter is HTML, they work with HTML really nicely. So you can make really advanced visualizations and customizable widgets using HTML. And then another thing that I find really helpful is, again, we're really just like playing with the innards of the HTML right now. And so normally when you use the head command on a data frame, you get the first five rows. If I want to do the head and if I want to see the head and tail, I can't. Well, I will because I already sort of jumped ahead of myself because I had practiced and ran this already. But what this is going to do is it's going to edit the actual setting that tells you how many things get displayed in one cell. So normally, if you run that, only the first thing that you display will show up, and the last thing. In this case, you can have as many things displayed as you want. So by changing this, I can look at the head, the tail, I can describe the data frame. Normally, it's, again, like a very hacky efficiency thing. You might have several cells to do each one, but now I can do them all in the same place. You can take this even further, like say you want the head command to do something differently, like show more columns or show more rows, you can customize that. You can have like filters inside of the actual cells themselves. It's pretty extensible, sort of the underlying theme of most of this. Running down the list, time it is really useful if you want to test the efficiency of a function or something that you're testing. It's basically going to run whatever you give it 1,000,000 times and see what the average rate or the average speed of the actual loops were. Just easy way to quickly check if your computer counts as fast as you expect it to. And then lastly, this doesn't work in JupyterLab, but we're still in Jupyter. Everyone knows Matplotlib inline will let you display the results of your Matplotlib charts inline. Matplotlib Notebook is a newly, I guess not as newly released anymore, extension which will let you make these interactive. And so these are now, as opposed to static images. Let me zoom out. This is way too big. But the idea is these are now editable, and so you can like zoom in on a specific part of the graphic. It'll pop up with like a home button, and you can zoom in, filter, pan, all that good stuff. But it is a little slow if you render too much stuff at once. So that's the quick run through of some of the cool things you can do with Jupyter itself. Again, the main underlying feature here is that it's very extensible and it's all HTML based, and so if you can search Stack Overflow for HTML, you can get very creative with some of the stuff that you can do. And there's a host of open source projects related to it. So I want to also quickly show off Jupyter Lab, which is the hot new thing coming out of Jupyter. And so here we're looking at the same notebook that we were looking at before inside of Jupyter Lab. There's a small formatting things, like this ls command is a little smarter now, just like by default, you can search through it. But everything else functions exactly the same. And the file types of notebooks haven't changed, and how Jupyter Lab versus Jupyter renders the content hasn't changed, like minor cleanups. So all of your IPython notebooks that you're currently using, however you're using them, should work as expected in Jupyter Lab. But some of the cool parts of Jupyter Lab are sort of broken along two ways. One is just the more IDE-like feel that it adds. So I've been working on this train model.r script that I want to toss over here. And I prefer Python, so I'm going to try and retrain it over here. And then I also want to work from the terminal. So I'm going to pull this up and add these files. And so now I've like sort of tossed together an almost RStudio-like experience that I can now use in a web browser. I can customize what I'm seeing, where I'm seeing it, and I can edit the files, kick them off in pretty quick commands, and basically get a real experience as opposed to the single notebook that I've sort of been tied to before. And so it's a much more extensible way to work with Jupyter. It's also a much more extensible way to work with Python, but also, again, all of the other things that are available. And lastly, tie that one off. One more thing I want to show, which is sort of the other languages that are available. So the first notebook we were looking at was showing just using the various kernels that you can install inside of a single notebook. You can also, of course, change the native kernel itself. So there's a simple command to see all the kernels that are available on your machine. Plenty of instructions on how to add more kernels. This one has a decent number. The one that I am most impressed by is SAS, both for the technical ability of getting it into Jupyter, but SAS's willingness to let the open source community do that. And so I can do things like it's currently in Python, but in order to jump into Scala, which I believe is a little slow, I can simply jump into Scala, make that my editor, or make that my kernel, and kick off whatever Scala commands I want to run. Maybe I'm doing something like trying to translate between Scala and Python, or Python and R. And I have a really easy way to make sure that I can compare them side by side on the same hardware and the same infrastructure without having to do a pretty massive change management system to run extensive testing, which, to be fair, you should still run testing. But the ability to do it in a way, again, from the exploratory, like data cowboy side, makes it a lot easier to just use whatever tool is best for the job at hand. All right, so it concludes most of the things I wanted to cover. Kind of want to wait for the SAS kernel to finish just to prove it's possible. But again, because it's Jupyter, like you can now have like something that looks just like a Python notebook, but it's actually a SAS notebook, which is I find really impressive. And so I admittedly don't speak SAS, but all I have to do is paste this into the same notebook kernel, and I get the same outputs. And so people are familiar with SAS. I think that is SAS. And the idea is that, again, I don't really know much about what the standards are for SAS because I've never really used it, but I now don't really have to know what they are. I have to learn the language, but now I'm putting it in a language that people who are only familiar with the open source community, for example, like Jupyter Notebooks, know how to communicate with. They know how to work with it, how to render it, how to format it. And it really brings a level of standardization to a very messy world, which is data science tools. All right, that about sums it up. I have a couple more slides, which is that we're hiring. Domino is make the final pitch of the conference. If you haven't seen it already, we're hiring all over the place. So if any of these things or locations look appealing to you, let us know. And then this will be available after the conference. But all of the work that you just saw is in public Domino projects that you can go jump into a Domino project, spin up a notebook, and start playing around, grab the terminal, grab the commands, grab all the magics, all that good stuff. And then a few other good links that are related to stuff that was in there. All right, that's it, guys.